You can use the abstract factory pattern when a system should be independent of how its products are created, composed, and represented. Our real-life example nicely illustrated this. The client doesn't know about these concerns. Closely related to this, use it when you want to provide a class library of products and you only want to reveal their interfaces and not their implementations. The decoupling between client and factory and products is a win in this regard. Also, use it when a system should be configured with one of multiple families of products. As we learned, the abstract factory deals with product families, products that belong together. In that way, it's different from the factory method pattern. Also, use it when a family of related product objects is designed to be used together and you want to enforce this constraint. Let's cover the consequences next. This pattern, as most, has a few benefits and liabilities. First, it isolates concrete classes, because it encapsulates the responsibility and the process of creating product objects. In other words, clients are isolated from implementation classes. And that's mostly an advantage because it means that we are avoiding tight coupling. You can thus easily introduce new products without breaking client code. That means we're adhering to the open-close principle from the solid coding principles. Also, seeing the code to create products is contained in one place, we're adhering to the single responsibility principle as well. It also makes exchanging product families easy. Seeing the class of a concrete factory only appears once in an application, where you instantiate it, it's easy to change that concrete factory. You can switch it out for another one by changing that one line of instantiating code, as the rest of the system works on the interface and not on the implementation. It also promotes consistency among products. This is because products in the same family are created by the same factory. Seeing an application only uses one abstract factory at a time, the products that are used are related and compatible with each other. A potential disadvantage is that supporting new kinds of products is rather difficult. If you want to extend the abstract factory, you have to change the factory interface, which also means changing the implementation of all of its subclasses. And with that, we know a thing or two about the abstract factory pattern. Previously, we covered the factory method pattern. These two are closely related. Let's have a look at how they compare. Abstract factory is closely related to factory method. In fact, both are sometimes referred to as the factory pattern. As they're creational patterns, they're both about creating objects. But there's more ways of doing that. In fact, 2 more creational patterns are coming up. So, why are these two so closely related? Let's start with the factory method pattern. In essence, this means that we're creating an interface with a method on it, the factory method, to create an object of a certain type. Yet, what we work on, the object that's being returned, is never a concrete type. It's an interface or an abstract base class. The factory method only produces one product, and it creates these objects through inheritance by implementing the interface or abstract base class with the factory method on it. The abstract factory pattern, on the other hand, is signified by exposing an interface to create related objects, families of objects. For that, multiple methods are exposed on the abstract factory. Here too, just like with the factory method pattern, the return types of these methods are interfaces of abstract classes. And this is what is meant when it's stated that the abstract factory is often implemented with factory methods. Anyway, it thus produces a family of products. And it does that via composition instead of inheritance. The abstract factory contains fields that hold the concrete factories that are used for creating concrete products. Because these are so closely related, and because often the abstract factory is implemented with factory methods, when most people talk about the factory pattern, what they mean is a combination of abstract factory and factory method. Let's have a look into the related patterns for the abstract factory pattern. Abstract factory classes are often implemented with factory methods, as we just covered, but they can also be implemented using the prototype pattern. That's another creational pattern we'll cover soon. So in that way, the abstract factory pattern is also related to the prototype pattern. Also, a concrete factory, so an abstract factory implementation, is often implemented as a singleton. Let's have a look at the module summary. The abstract factory pattern is a creational pattern from the well-known gang of 4 design patterns. It's closely related to the factory method pattern. Its intent is to provide an interface for creating families of related or dependent objects without specifying their concrete classes. The main advantage here is that clients are isolated from implementation classes. In other words, decoupling. As far as implementation goes, this isn't the simplest pattern to implement. The most important part, however, is to keep on working on interfaces or abstract base classes. When returning concrete products, return them via their underlying interface. Up next is another creational pattern, the builder.